Good morning. It's a pleasure to be with you guys here in the Western School of Science and Technology. We have an algebra class today. I will talk a little bit about geometry because both concepts are used also in geometry, and the same concept is used in geometry and also in algebra. And it's a concept used in many situations in high school math, even in college. Hopefully, you guys are able to learn this right now because it's a very important concept. Okay, let's go. Linear functions, linear equations. The coordinate plane is used in geometry and algebra. I have two axes, the y in the horizontal line and the x, the vertical line. And I use those coordinates to allocate points, to find the position of a point. It's like an address system. Think about Phoenix. Phoenix is a city designed in a grid. You have the streets, 7th Street, 11th Street, 16th Street. So it's a grid like the coordinate plane. In geometry, a line is determined by 2 points. Each point in the coordinate plane has the x position and the y position. If I want to draw a line, I need to know at least 2 points. Connecting those points, I'm able to draw a line. In the coordinate plane, you have 2 points determined by x and y, and the y usually is calculated based on the x value. And you have an equation that forms that line. So you have an x, you have an y, and the relation between x and y is determined by an equation. I'm highlighting this part, so make sure you have this on your notes. In this picture, I'm showing you I have 4 points, and I also have the equation of a line that is created by connecting those points. So I have the first point x0, y15, x10, y35. The third point x20, y55. All of those 4 points are determined by this equation, y equals 2x plus 15. Important thing in this slide, the line in the coordinate plane is represented by x and a y, and they are connected through the equation y equal mx plus b. We're going to talk later what is the meaning of m and what is the meaning of b. Linear functions, algebra applications. In the last slide, we were talking about geometry, line, points. But, as I said before, we have algebra applications for the line, for the graph, and for the equation. In algebra, you use y equal mx plus b to create models. This is an equation. Algebra is all about equations, models, and graphing. I have 2 variables in this equation, x and y. And they are related through the function function of x. Please put this in your notes. X is the input, y is the output, also called function of x. The equation is y equal mx plus b, and function of x equal mx plus b. We have a typing mistake, also called function of x. Okay, make sure you have the red text in your notes. Using algebra to model a real-life problem. The price of a taxi cab. If you go to the airport and you need a taxi cab, the price of a taxi cab is given by the minimum fee for the ride is $15. The cost per mile, $2. So, what is my total price, my total cost? Can you write an equation, an algebra model, to calculate the cost C of a ride based on miles? X is your input, cost is the output. When I talk about X input, Y output, we are talking about functions. In the next weeks, we are going to talk a lot about that. So I'm starting with the basic concept, the equation of a line, and then we are moving forward in functions and many concepts, many additional concepts related to functions. We are going to have fun for sure. Solution for the taxi cab problem. The total price is the sum of the minimum fee, $15, and the cost of all miles rode, $2 times the miles, or 2 times x. I will give you 15 seconds to try to write by yourself the equation which solves this problem. Okay? It's important to try by yourself. The cost is $15 plus 2x. Remember that $15 is the minimum fee when you enter the cab, when you call the cab, you need to pay for that. And you pay $2 for each mile that you ride. Remember that the miles that you are riding is represented by x. In usual math language, we write down this model using y equals 2x plus 15. This is a simple model. Creating those models is not our job for today. We are gonna work a lot on that, but now we need to understand how to use how those equations work. Let's move. Linear equations. A linear equations is one math model given by y equal mx plus b. Sometimes you need to combine like terms and use distributive and associative properties to get the form presented above. What I'm saying is, sometimes you don't have this form. You need to work a little bit to get the equation in this form. I will give you some examples right now. Take a look at example number 1. It's easy. Y equals 2x plus 1. It is in the form that you are used to y equal mx plus b. In the second equation, we have some differences. Your y is multiplied by 3. Your 6 is not close to 5x. So, in this equation, we need to manipulate the expression to get the form y equal mx plus b. I'm going to talk a lot about other forms on the linear equations. You guys don't need to be worried about that right now. We have a specific class to talk about different forms of linear equations. It's not our goal today. The representation in the coordinate plane. The graphical representation in the coordinate plane. The linear equation y equals 2x plus 15. How can I represent that in the coordinate plane? You need to use a table to find some points. You need to plot the points in the coordinate plane. And the last step, connect the points to find the line. When I'm talking line, I'm talking about the graph. Line reminds to geometry, but I'm using the same concept in both subjects, geometry and algebra. Let's move ahead. Well, you see a table, you see the x value, 0, 10, 20, 30, and you also see the equation. The equation is y equals 2x plus 15. I need you guys to pay attention. There is a small mistake. It's 2x plus 15, not 2x plus 1. Okay, the first step, I need to fill the table with the information. For x equals 0, I want you to plug it in the 0 in the equation. 2 times 0 is 0, plus 15 equals 15. Now, take a look in the table after using the equation. For x equal 10, I will have 2 times 10, 20, plus 15. So I have y equals 35. Remember, we are using the coordinate plane. For each x, I have one value of y. Going to 20 in my table. 20 times 2, 40, plus 15, 55. And the last point in this table, you have x equal 30. Y equals 2 times 30, 60, plus 15, 75. So your last point in the table is x equal 30, y equals 75. This is the step-by-step. Find the x and y coordinates for each point and plot one point each time. You need to draw a line. To get a line, I need at least 2 points. Okay? This is my second step. My advice for you is try to use the point x equals 0. Why should I use x equals 0? To make your math easier. Take a look, you are multiplying. 2 times 0 is 0. Plus 15, 15. Okay, When you get the points using the equations, you can draw a line connecting your points. Take a look. This is our table. Let's go to our graph. If you take a graphing paper, you can draw the points x0, y15, x10, y35, x20, y55, x30, y75. All those points are ready to give you a line. Just connect those points. That's it. Now you see the 4 points that I have and the line. Remember, I just need 2 points. I don't need 4. I was just presenting you an example. Okay? Questions so far? Let me know, please. The y-intercept when we are talking about linear equations. The equation y equal 2x plus 15. What is my y-intercept? Please take a look in the picture. You have a red point crossing the y-axis. The point is the 0, 15. It is an important point because x equals 0. When you know this point, it's much easier to know which line we are talking about. Take a look. It's a particular point. The line just crossed the axis once. So it's important to know this point. Knowing this point, it's the solution for many algebra problems. Let's move ahead. Take a look in your table. X equals 0. X equals 0, y equals 15. I'm sorry, let's go. Talking about slope. Slope is another property. It's a very, maybe it's more important than the y-intercept. The slope tells me how steep is the line. The slope is the number that multiplies x. So, the slope gives me the steepness of the line. The greater the slope, the line will be closer to the y-axis. In the opposite way, the smaller the slope, the line will be closer to the x-axis. I'm sorry because I need to add this information, put this information in your notes. So, just repeating this, the smaller the slope, the line will be closer to the x-axis. First, the greater the slope, the line will be closer to the y-axis, and in the opposite way, the smaller the slope, the line will be closer to the x-axis. I have two situations. My slope could be positive or could be negative. The positive slope, I have a positive number multiplying x. If x increases, you see the line y increases as well. If your slope is negative, If x increases, y will be reduced. I have something to show you before moving to this slide. 1 second. Okay. I need to simulate with you. I'm able to simulate what happens when you change the slope. One second. That's it. Sorry about the delay. Okay, let's play a little bit with the slope. In this picture, I have a slider and I can play with the slope. If I change the slope, I'm changing the graph. I told you the greater the slope, the line will be closer to the y-axis. Can you see? The smaller the slope, the line will be closer to the x-axis. Okay? So, when you increase the slope, your equation is growing faster and the line is getting closer to the y-axis. If you reduce your slope, your equation is growing slower and the line is getting closer to the x-axis. I told you another important topic. If your slope is positive, the y values are growing. As you grow your x values, the y are growing as well. On the other hand, if your slope is negative, the greater the x values, smaller the y values. I usually say positive values of slope, the line is going up. Negative values of slope, your line is going down. Okay? We are going to have practice on this, okay? Don't worry about that. Let's go back to the next slide. One second, so I can get ready for the next slide. Okay. One second, please. Okay, let's go back. I'm sorry for the delay. Okay, we move it too fast. The slope formula. The slope formula is a very important topic. Please write this down in your notes. The slope is calculated by the formula m equals y2 minus y1 divided by x2 minus x1. Why am I using 2 and 1? I have 2 points in the line, point 1 and point 2. So if I want to calculate the slope of that line, you need to use those 2 points, label the points you choose. Remember, the line you have infinite points, so choose 2 points, label them, and you have x2 and y2, x1 and y1. When you have the 2 points, just use the formula. Okay? You can see in this picture, rise. It means the function is the line is going up, and run. Run means x is going up. Okay? I will tell you something right now, it's very important to remember. The slope is also called rise over run. Your rise is the movement in the vertical. y2 minus y1 divided by run. Run is your movement in the horizontal line. x2 minus x1. Save in your brain, in your mind. The slope m is calculated by rise over run. Step by step, choose any 2 points in the table, apply the formula y2 minus y1 and x2 minus x1, divide both of them, and to remember how to calculate the slope, remember rise over run. Choose 2 points. You can choose any points to calculate the slope. You can use 10, 35, and 0, 15. 35 minus 15, 20 is my rise. 10 minus 0 is my run. So 20 divided by 10 equals 2. What is the effect of change m and b? We already did that. So when I change the slope, I'm changing the steepness of the line. Practice. Find the linear equation from the graph. Find the y-intercept and calculate the slope using 2 points. Write down in your equation. I'm sharing with you this worksheet. So, just an example. How can I calculate my y-intercept? My y-intercept is the point in the graph. My y-intercept is the point in the graph where x equals 0. So for this example, my y-intercept is is 4. How can I calculate my slope? You have the rise and you have the run. Take a look. This is a trick question. My line is going down, so my slope is negative. Okay? My rise is negative. My run is positive, but my rise is negative. Okay? Let me see to help you. For this graph, my rise is negative 4. And my run looks like 3. Okay? We're gonna work on this. We're gonna have time to have practice on this and to take all your questions and make sure you learn this first step, this class today. As I told you, we're going to stay on this subject for some days. Let me show you our next steps. The next steps are find the equation using one point and the slope, find the equation using a table with points, find the equation of a line using the graph, and we're going to talk about applications. We have a lot of applications in physics, economics, and business, and in other many fields you can imagine. Okay? So let's work on the practice. And please let me know if you have questions about this. Okay? Thank you so much at this time. See you.